Thank you, everybody, for coming to the 7th Sudden Oak Death Science and Management Symposium, although I guess this is the first time we've actually had the word management stuck into the title. We have people here from all over the place, 10 different states, Washington, D.C., 5 different countries, so welcome, everybody. I think we have some really interesting talks coming up over the next couple of days. I'd like to start off by thanking our various sponsors. And I didn't have to use these in Sudden Oak Death Science Symposium 1. So here's our sponsors, but I still read them off. We have the National Park Service, Muir Woods National Monument, the Golden Gate National Parks Conservancy, One Town, UC Cooperative Extension, Marin County, San Francisco Public Utility Commission, Cal Poly University, Marin Municipal Water District, the Presidio Trust, Cal Fire, California Native Plant Society, okay, great, there's a lot. Mid-Peninsula Regional Open Space District, the California Forest Pest Council, and of course the California Oak Mortality Task Force. I'd also really want to point out the USDA Forest Service, particularly Forest Health Protection, Pacific Southwest and Pacific Northwest regions as far as really helping get this meeting going. So let's thank all those different organizations. I'd also like to thank all the meeting organizers, and putting together a meeting like this is never trivial. So I'd like to thank Janice Alexander and Bonnie Nielsen. Stephen Swain and Dave Lewis from UC Cooperative Extension, Chris Lee, Dan Stark, who's moving to Oregon, so this is his last hurrah on Sudden Oak Death. Susan Frankel, of course, Krista Comporti from the Presidio Trust, Alyssa Shore from Golden Gate National Park Conservancy. And on the field trip, we have the Marin Municipal Water District in Muir Woods, who are really playing a big part in that. So let's thank all those folks too. So each time we've had, this is again our 7th symposium, where we're learning more and more about these different pathogens. In the case of Sudden Oak Death, we had really heavy rains 2 years ago, heavy rains this year, so we're starting to see the mortality from 2 years ago infections, and that will continue into the future. So there's still a lot to be learned, and hopefully we're going to learn some new things today with that. But we don't want to forget things. For example, right now, Phytophthora was shipped to 18 different states and nurseries with recalls via Indiana, so there's still a lot going on with Phytophthora rumorum there. And day 2 of this meeting, we're also going to be looking at other phytophthores, and this is something that I think came out of some of the initial work on Sudden Oak Death through the nurseries. We're looking at restoration, and there's a lot of amazing work going on here in California and around the world. We're going to hear from other locations in the world, New Zealand and posters from Chile. So there's a lot of work going on there. We also want to think that, tomorrow we have a sort of a special thing with Amber Ginsberg and Sarah Black from the Art Institute of Chicago, and you all got a pencil that was made from an infected camo. Tomorrow we're going to hear from Amber and Sarah about their vision and what that came about. And I'm particularly interested in that, because at UC Davis I oversee a program called Art Science Fusion, so I've always been really interested in that topic. I think that really is going to bring something home. It is somewhat of a changing of the guard here since Sudden Oak Death Science Symposium 1. I've risen from giving sort of a plenary talk to telling people where the bathrooms are. They're out the door and back there, by the way. So I've really risen to the top here and not giving any talks at all. But to see some of the younger folks who got started partway through, I was showing the folks in my lab the other day my original notebook. So on June 14th, 2000, the hottest day in the history of San Francisco, Susan Frankel, Everett Hansen, and my technician friend Gary Slaughter went out to Muir Woods in Chinatown State Park. That was on June 14th, June 16th, I did the isolations in the lab, and June 19th, my handwritten notes say, Sporangia unknown phytophthora. And so that was the first time I'd ever seen what became Phytophthora worms. That was 19 years ago. So a lot has happened in those 19 years, learning about the biology of Phytophthora worm and other phytophtheras in forest ecosystems, and we're still trying to learn about management. I'm going to stop there and turn it over to Blakey. He is to start our first session. So I'll turn it over.
So, good morning and welcome to the first panel of the symposium, which is titled Sudden Oak Death in Oregon. My name is Blakey Lockman. I'm the Regional Forest Pathologist for the Pacific Northwest region, which covers Oregon and Washington. And I'm actually relatively new on the sudden oak death scene. I spent the majority of my career in Montana, and being very grateful and thankful that at least we didn't need to worry about sudden oak death. And now I find myself in the Pacific Northwest region, smack in the middle of some of the discussions with sudden oak death, and I lean pretty heavily on those people that have spent the majority of their career working on sudden oak death, which includes our first speaker, which is Sarah Navarro. Sarah is, she's going to kick off the symposium with her presentation. Sarah is forest pathologist for the Oregon Department of Forestry. She has worked on Phytophthora as an undergrad in Dave Grislow's lab and as a grad student at Oregon State University. So Sarah's very calm demeanor has seen her through a number of sod challenges, including the discovery of the EU1 in Oregon forests in 2015, to being on the speed dial for the staff of a U.S. senator. Sarah's presentation is Slowing the Spread of Sudden Oak Death in Oregon Forests from 2001 to 2018. So please welcome Sarah.
Figure it out for you. Thank you, Blakey, for the introduction. I always like to start off my presentation with my acknowledgement slide. It's something that Alan Kanaski, my predecessor, always did. And I think it's really important to tell everyone that our Oregon story is not just one person, it's not just me, it's everyone working on sudden oak death and the management of this disease in our Oregon forest. So it's myself, my colleague, Sarah Nichols, who is here today, as well as our other sudden oak death forester, our counterparts with the U.S. Forest Service, retired pathologist Ellen Goheen, and her newest sod forester on the ground in Gold Beach, and then Oregon State University. We lean very heavily on them for all of their scientific knowledge and the research that they're continuing to do. The Oregon Department of Agriculture we work very closely with, as well as the Bureau of Land Management, South Coast Lumber, who's the largest industrial timber owner in the area, and then lastly, the landowners of Curry County. Slowing the spread of sudden oak death would not be possible in Oregon without all of these key players. So just a couple background for everyone about sudden oak death in Oregon. So it's been introduced into sudden oak death has been introduced to our Oregon forest 3 times. The first introduction was most likely in 1998 through infected nursery stock from California. The second introduction was in 2010 up near Cape Sebastian State Park. It was 12 miles away from any known infestation at the time. Again, most likely infested nursery stock. And then our third introduction was most likely in 2013, but detected in 2015. And that is the European lineage of Phytophthora morum up near Pistol River, very close to Cape Sebastian. So we've had 3 separate introductions in Oregon. And unlike in California, tan oak is the key host species in our Oregon forest, and it's what drives the disease in southwestern Oregon. Oregon myrtlewood or California bay is not a factor in disease spread in Oregon. If ever I want to get a rise out of Everett, I call it California infected when they're grown within close proximity to these infected tan oak canopies. And then here is, eventually, this is what's going to kill the tan oaks in both California and Oregon, is those stem girdling lesions. And so our sudden oak death program in Oregon is comprised of 5 components. We have survey and detection. We do 4 helicopter flights per year, along with 1 fixed-wing flight to identify all new outlier infestations. During the helicopter flights, we are individually GPS marking infected tan oaks and then going and surveying them on the ground. We also do stream baiting, so we monitor at least 50 stream courses, both in and outside our sudden oak death quarantine area for new infestations. And then we also do ground transect surveys in high-risk, high-priority areas to be able to delineate infected sites and set our treatment areas for the year. And so once we have new infested sites, we go in and delimit the area to find all infested trees. We then set our treatment areas based on that. Ideally, our treatment areas are 300-foot buffers, some monitoring and continued research in our Oregon forests through Dr. Jared Boldis' lab. So sudden oak death in Oregon, it's regulated under a state quarantine, which is through the authority of the Oregon Department of Agriculture. It was established in 2001, and it requires private and state landowners to treat sudden oak death on their property. ODF pays for these treatments when required under the quarantine. So you'll see in the animation on my slide the evolution of our quarantine boundary in Oregon. It has evolved with the spreading of the disease, as well as in 2012 with the generally infested area being created. We shifted in 2010. We started off as an eradication program in 2001 and shifted in 2010 to a slow the spread program because the amount of disease outstripped the funding that we had for treatments. And so the generally infested area was established and treatment is no longer required on private landowners. However, the Bureau of Land Management still treats sudden oak death on their property within the generally infested area. So what is a sudden oak death treatment? So for our treatments, we do host buffer removals. So for an infected tree, we treat as much as 300 feet around an infected tree where we're removing all of the tan oak within that buffer. We herbicide inject the stumps to prevent resprouting, and then we cut, pile, and burn all of the tan oak within that 300-foot radius. For one tree, a 300-foot radius equates to about 6 acres on the ground. As you can imagine, it's very labor intensive, and so the costs are typically $3,000 to $5,000 per acre. It's averaging about $5,000 per acre these days. And as I mentioned earlier, there is no cost to private landowners for this. We use contract crews to do the work, but we don't compensate the landowners for the loss in tan oak on their property. So far, Oregon, we've treated about 6,800 acres. 25% of this has been on federal lands. So between 2017 and 2019, we have seen an increase in disease in our Oregon forest. We see the majority of the spread just north of our generally infested area, as well as up the Checco River drainage and then up the Winchuck River drainage. And so these are where we've been setting our treatment priorities within the last 2 years. We've been heavily treating the EU1 lineage up in this Cape Sebastian Pistol River area. We had one of the largest wildfires in Oregon's history in 2017, the Checco Fire, which burned almost 200,000 acres. And Hazel Daniels will be talking later on about her project monitoring the sudden oak death sites that burned during that fire. And so we have had to expand the generally infested area recently, and we will most likely expand it again this year because the amount of disease does outstrip the funding that we currently have. So for the touching on the European lineage infestations, at the last SOD symposium, Alan Kanaski presented on this, and that at the time we had not found, at the time we had treated this one 13-acre infestation and no positive trees had been found post-treatment, and we had one positive soil sample post-treatment. Well, go to today, we have now treated over 473 acres of EU1 infestations with about the same amount left to treat. We have received increased state funding for specifically EU1 treatments within the last 2 years. We've received $1.6 million of state funding to treat the European lineage. Our state legislatures are very concerned about the European lineage because of the mortality in Douglas fir and other conifer tree species that they see in the United Kingdom. At this point, we have talked to our legislatures and policymakers that eradication of the EU1 lineage is most likely not possible given our current funding and resources. We're being realistic and upfront with them, and that we can continue to slow the spread given the current resources that we have. So what do these resources look like? We have received an uptick in funding within the last 2 years in Oregon. It's been a stable trend mostly in federal funding. Our Sudden Oak Death Task Force, which I will talk about next, has led to an increase in state funding. We have a new NRCS equip sod project where we're working with landowners for a cost share for treatments, and we're going to be trying to sign up landowners within that generally infested area this next go around to try to get that mortality off of those sites. And then we have seen increased research funding through USDA ARS. So in Oregon, we have a newly formed task force. It was established in 2016 through a block grant of the Association of Oregon Counties. It was originally co-convened by our U.S. Senator Jeff Merkley and State Representative David Brocksmith. Most recently, Senator Merkley has stepped down, and we have another state representative, Caddy McEwen, in his place, but he's still very much involved, sending his staffers to all the meetings and calling in on our monthly Oregon sod call. When the task force first convened, they determined to set up 6 subcommittees, all focused on different aspects of sudden oak death in Oregon. These subcommittees met and made recommendations to the task force, which was eventually adopted into a strategic plan that was set forth in May 2017. It included all recommendations, such as from the All Lands Committee, forming a memorandum of understanding between all members of the task force. There are over 30 member organizations of the Sudden Oak Death Task Force in Oregon. We have representatives from federal agencies, state government, federal government, as well as tribes and other organizations such as the Port of Coos Bay, Weyerhaeuser, as well as other local entities. And so they also identified funding requests and recommendations. And then one thing that we have completed from the strategic plan is an updated economic impact assessment for sudden oak death in Oregon. And so the assessment, ODF funded the assessment through the recommendation of the task force. The assessment was an updated version of the one produced in 2009 by Kim Hall at Oregon State University. And so the assessment looked at the economic impacts since the discovery of sod in 2001 up until 2018 on Oregon, and then it looked at potential future economic impacts from 2019 through 2038 for the 4-county region that could be affected by sudden oak death in Oregon under these 3 scenarios. So halting current treatment regime as of January 1st, 2019, continue our current slow the spread program, and then a scenario of focusing just on the European lineage in our Oregon forests. The assessment also examined non-timber impacts, many of which are hard to quantify with economic value, but it was good to include in this report to make it as comprehensive as possible. So these included impacts to property values in the area, impacts to ecosystem services, cultural values, and then wildfire risk and public hazard. So what they found is current impacts. So the current impacts of sudden oak death, they found no detectable job or wage losses from 2001 to 2018. Moderate job gains through the staff that ODF and the Forest Service employ in the area, as well as our contract treatment crews. So that's a positive. And then undetectable impact to timber export value via the Port of Coos Bay, which is the largest international export port within the Southern Oregon region. Future impacts, what they found, that if we were to stop treatment as of January 1st, 2019, the impacts could include, but they did not quantify the potential of these happening because that would be very hard to do. But these impacts could include sanctions on timber exports by China, Japan, and or Korea, the loss of 1,200 jobs related to timber export, which equates to about $58 million in annual wages, the reduction of timber harvest by 15%, and then a decline of rural residential property values. If we were to continue the current treatment regime, we could offset this timeline from as soon as 2028. These impacts occurring, it could be offset to 2038 if we continue to slow the spread of sudden oak death. So this continuation and offset really says that if we do continue to treat within the next 10 years at a total cost of next 20 years at a total cost of $30 million, we could offset the loss of jobs as well as $580 million in wages between those 10 years. Some of the non-timber impacts that were found through interviews with the tribes as well as local residents and local organizations, impacts to cultural practices with great historic and traditional meaning, including acorn gathering, gathering of materials for basket weaving, and hunting were already being compromised by sudden oak death in southwestern Oregon. Reduced rural residential property value. They based this off of the Marin study from 2011. They found about a 5 to 6% property value loss in the generally infested area, a potential decline in recreation and tourism in the future if unfavorable public perception of the region takes hold due to the die-off of the tan oak trees. And then lastly, a key concern voiced during the interviews was the potential increased wildfire risk with those stands of dead and dying trees within the generally infested area. That slide that I showed earlier on with the Checo bar fire, that came within 7 miles of that generally infested area with all of that standing dead dry fuel, and it scared a lot of local residents. Shifting gears now, I know that originally on the agenda, Alan Kanaski was going to present on the intensification of spread of sudden oak death in the absence of eradication treatments. I graciously offered to present this information because I think it's important, and he kind of duped me into it, but I'm happy to do it. So this is a photo within that generally infested area. This was originally started to decline about 4 years ago and is now since just completely falling apart. These trees are falling into the road, and this is a one-way in, one-way out road, not county maintained. So we in Oregon have been obtaining higher resolution digital imagery since 2012, since the beginning of the generally infested area. It's 30 centimeters resolution, so about 1 foot. And using the boundary of the generally infested area 4, which was established in 2015, I'm going to track recent tan oak mortality through the creation of this 500 meter by 500 meter grid. So these grid cells were allowed for systematic examination of the imagery. So looking at the 500 by 500 grid, what Alan did with the imagery is he sketch mapped all recently dead tan oaks in a manner similar to an aerial observer, but at a finer scale because he is at a computer instead of in a fixed-wing aircraft. And so this image, you can see both healthy and dead, and then some long dead trees within this polygon. The polygons provide a conservative estimate of the infested area. And to avoid double counting throughout the years, where we looked at this imagery, we used cumulative area of dead trees as opposed to individual years. So what does this look like on the landscape compared to our sudden oak death treatments? So the yellow is the mortality polygons that were mapped. The green is areas of treatment, and then the pale yellow blocks is BLM ownership. And so we'll go through the years imagery now. So in 2012, the establishment of the generally infested area, we see conservative mortality jump to 2013, 2014. You'll notice that there's high mortality in this area, which a lot of it is small private landowners, rural residential area, as opposed to a more industrial managed landscape of BLM and South Coast lumber. Jumping ahead, so remember this is all cumulative mortality as well. So lastly in 2018, and then when we compare with the sudden oak death treatments in the area, there's clearly been a large increase in the untreated infested area when comparing ownership, the BLM and private, versus the area right inside the originally created generally infested area. Looking at cumulative infested area in the generally infested area versus outside of the generally infested area, you see high rates of mortality. And then when we compare watersheds, so we have the Thomas Creek Cape Farillo watershed versus the North Fork Chetco watershed, we see much less infested area in the North Fork Chetco versus the Thomas Creek. And as I mentioned earlier, the BLM within the generally infested area has been treating their ownership within there. So notice the pattern of mortality versus ownership. So why do we see these differences? Is the amount of tan oak, is it the climate, proximity to coast and fog, is the risk of sudden oak death greater in one watershed versus another, and then again looking at the majority of ownership. There are two major differences. Number one, the North Fork Chetco infestations have been replaced with managed productive stands, and then secondly, there has been less inoculum available in this area for at least a shorter amount of time, likely reducing long distance spread and fire hazard and endangered trees. So looking at the abundance of tan oak, based on GNN data, there is or was more tan oak within the North Fork Chetco watershed than the Thomas Creek watershed. And then looking at the risk model, the North Fork Chetco does have a higher risk than the Thomas Creek. So looking at this from a treatment perspective, eradication treatments could have several benefits. So see less inoculum to support long distance spread. Infested areas have been replaced with young productive stands, and then a reduced danger from wildfire and reduced danger from falling trees. And so what does this look like visually on the ground? This is a photo from that Thomas Creek Cape Farillo watershed with the dead standing tan oaks within those stands versus one of the sod treatment areas within that North Fork Chetco.